When a customer opens a bank account from their sofa, how can the bank really know who's behind the screen and trust that identity across borders? In this module, you'll architect that bridge: robust identity proofing and seamless eIDAS-EID integration. You've already seen the foundations and framed our banking use case. Now we start turning that into a concrete technical solution. In this part, we'll zoom in on identity proofing, how the bank actually verifies who the customer is in an eIDAS-compliant way. When a customer first appears online, they're essentially just someone with a device. To open a bank account or sign a contract, the bank must turn that anonymous journey into a verified KYC-compliant identity record. Identity proofing is the bridge. It connects user inputs and external checks to the bank's core systems, producing a trusted digital identity with a known assurance level. Everything else in our eIDAS solution will rest on this verified foundation. Levels of assurance are the system's confidence levels in someone's identity. At low, only light checks are done. Fine for low-risk access, but not serious commitments. Substantial means stronger, better documented proofing, suitable for medium-risk use cases. For qualified electronic signatures, eIDAS expects high. That implies very strict identity proofing plus secure authentication, because the signature will be treated like a handwritten one in court. Designing remote identity proofing is really about choosing between three trade-off profiles. Video identification delivers a high assurance level, but requires human agents and creates more friction and higher operational cost. Document scanning with liveness can still reach substantial to high assurance, while staying self-service and fast at the price of more advanced SDKs and AI. National eID schemes provide high assurance with a smooth redirect experience and relatively simple API integration. Video identification tries to replicate the assurance of sitting in front of a bank clerk. The customer appears on live video, shows their ID, and often performs liveness actions like turning their head or speaking. A human agent, an AI system, or both, then check. Does the person look real? Does the document look genuine? And do they match? The whole interaction, plus the extracted attributes, is stored as evidence to support eIDAS requirements and later audits. The second identity proofing pattern is document scanning plus liveness. The user scans their ID with the camera, and software automatically reads the MRZ or ICAO zone to extract data. At the same time, a short selfie video or guided face scan confirms that there's a real, live person present, helping to prevent photo or screen spoofing. National eID schemes let the bank rely on a government-issued digital identity instead of manual document scans. The user authenticates with their national eID. The identity provider sends a signed token containing key attributes like name, date of birth, and the level of assurance. The bank server trusts this token because it's backed by eIDAS rules and certificates. You get high assurance onboarding with far less friction and fewer fraud-prone manual checks. Risk-based orchestration means we don't send every customer through the same proofing journey. A risk engine looks at real-time signals like IP, geolocation, device fingerprint, and past behavior, then chooses the most appropriate method. Low-risk or known eID users can go straight to eID integration. Medium-risk users might complete a document scan. High-risk or suspicious cases are escalated to strong, high-assurance video identification. You can think of the eIDAS node as a translation gateway for identities. The bank integrates once with this gateway instead of separately with every national eID scheme. When a foreign customer logs in with their national eID, their own country's system talks to the gateway. The gateway talks to the bank, and standardized identity data is delivered back. This reduces integration effort, centralizes trust management, and makes cross-border onboarding realistically scalable. Now let's focus on how identity actually crosses borders in a controlled way. The customer chooses their home country and is redirected into their familiar national eID system. That foreign eID provider authenticates them and returns a set of verified attributes. The eIDAS node in the middle acts as translator and gatekeeper. It converts protocols, applies policy, and forwards only what's needed. So the bank receives trustworthy identity data without integrating every foreign system directly. When you integrate multiple eID schemes, each one sends attributes in its own format. The mapping and normalization layer hides that chaos from the bank's systems. It takes variations in name fields, person identifiers, and levels of assurance, and converts them into a single internal customer model: legal name, national ID, verified status, and so on. If you design this carefully, adding a new country or provider becomes mostly a configuration task, not a redesign. Once identity proofing completes, the output splits into two different life cycles. First, stable reference data like name, date of birth, and address is extracted. That lives in the customer master systems and is used every day for KYC and servicing. Second, the heavy evidential data goes to a secure audit vault. That includes videos, document scans, and cryptographic logs, retained immutably for disputes and regulatory inspections. In a real eIDAS onboarding flow, the happy path is only half the story. You also need clear routes for when proofing isn't good enough, or when something looks risky or simply breaks. One branch is quality-based. Maybe attributes don't match, or images are blurry. Those cases can go to manual review. Another branch is risk-based, fraud suspicion or technical failure. That should trigger alternative methods, like a different provider or even a branch visit, instead of simply dropping the customer. You've now designed the foundation for trusted signatures, clear identity proofing patterns, an eIDAS gateway to connect schemes, and KYC storage to hold verified attributes. With identity in place, you're ready for the next step: orchestrating a qualified electronic signature that is legally robust and repeatable.